Okay, it's Mr. Thompson with a science video lesson. Still in physics and talking about work and energy. Bit of an introduction to these concepts, so let's get started. First, we will define work. Okay, work is when a force is applied to an object and the object moves in the direction of that force, and that's obviously as a result of the force. Right? Now the movement is underlined here. That's important. If it doesn't actually move, it's not counted as work. So for example, if we are lifting some weights in the gym and we pick a barbell, whatever, some weights off the ground and lift it up, as we move it, we are doing the work. But if we just hold it and we're not actually moving it, then that's not work. Even though we have to exert effort, it feels like work to hold it there. That's not actually doing work, technically speaking, in physics. So that movement is important, and it's in part of the equation for work. Work equals force times distance, okay? And that's all there is to it. Pretty simple. Let's work out the units, though. The units for force are newtons, and the units for distance typically is meters. That's our standard unit for distance. I know there's other things we can do, but those are the standard units. So the units for work are Newton meters. We don't do anything sort of fancy with them or make up something new. They're just Newton meters. Pretty boring, but you'll see another type of unit with energy here in just a minute. Okay, so let's look. Before we do that, let's look at an example of work. So a 5 kilogram weight is moved 40 centimeters with a 49 Newton force. Find the work done. Okay, well, we know that work is force times distance. So the force is 49 newtons and the distance is 40 centimeters. So we're just going to multiply those. Okay, so we're going to do 49 times what? Now, the units for distance are in centimeters, and we want them in meters. We want newtons and meters. So we're going to change the 40 centimeters to 0.4 meters, which gives us 19.6 Newton meters, right? Those are our units, okay? Now, what you've done there by doing work is you have transferred energy into the weights, right? You have put energy in, and you're using energy to hold it there, your bodily energy. And that barbell has energy in it. You have transferred energy into it. So let's define energy. Energy is broadly defined as the ability to do work. So you can see energy is defined in terms of work, and oftentimes work is defined in terms of energy. So work is the measure of change in energy. Okay, so when you lift up weights, you are putting energy into those weights. All right. Now, energy has more interesting units. You might have heard of them on the back of a packet of food or something. It says the energy, and it might have joules. In places like America, they have calories. But 1 Newton meter of work is 1 joule. Okay, and it seems like that means they're the same thing, right? Well, they convert 1 to 1, but that doesn't mean work and energy are the same. Okay, so in our previous example, 19.6 Newton meters is going to be 19.6 joules of energy. And what we've done is we have put the energy into the weights as potential energy. Okay, it's stored energy. So there is energy sort of sitting in those weights, not like inside like how food gives us energy, but there is gravity is going to pull that barbell down, and it's going to create that movement, do the work. If we drop it, gravity does the work to release the energy. So it had potential energy, gravitational potential energy, being up in the air, and when we drop it, that releases that energy. So we put the energy in by lifting it, we release it by letting it go. And it when it's moving down, it's kinetic energy. It's gaining kinetic energy. It had some kinetic energy when we moved it up as well. Probably not as much though. Now, potential energy is an important thing to understand. So there's lots of different types. One we've already talked about, which we'll get to, but One type of potential energy is elastic potential energy. So if you stretch a rubber band, an elastic band, or a spring, okay, and it wants to pull back together, that is elastic potential energy. Or if you compress a spring that then wants to open back up, same thing. The one we've already talked about is gravitational potential energy. And it is something that could fall, right? Something that's up high and has some space to fall down, some distance to fall down, like our weights, or maybe an apple in a tree or something like that, right? Electrical potential energy is when there is a buildup of a positive or negative charge. A classic example is clouds. They build up an electrical charge, and then that is released through lightning, right? But while it's in the clouds, that is electrical potential energy. Chemical potential energy is a subset of electrical energy because it has to do with the electrons in atoms holding atoms together and making bonding compounds and things like that. Keeps all of matter stuck together, right? Chemical potential energy. And then finally, for us today, is nuclear energy, which is stored in the nucleus, the protons and neutrons of an atom. And it's what nuclear power plants are harnessing when they're creating energy, and what is released in atomic bombs and stuff like that. So work, the force times the distance when a force makes something move, and energy, where 1 Newton meter equals 1 joule, and all these different kinds of potential energy. That's it for today. See you next time.